Hello and welcome back to our class. This is teacher Onen de Guzman, and our topic for today is solving quadratic inequalities. A quadratic inequality is just like a quadratic equation, except instead of an equal sign, there is inequality. So check this one out to see the characteristics of quadratic inequality and get some practice identifying them. Quadratic inequalities in one variable are inequalities which can be written in one of the following forms. We can have ax squared plus bx plus c is greater than 0, or we have ax squared plus bx plus c is less than 0, or ax squared plus bx plus c is greater than or equal to 0, or ax squared plus bx plus c is less than or equal to 0, where a, b, and c are real numbers. And take note that a should not be equal to 0. Otherwise, it will result only to linear functions or equation. So let's have example number 1. Say for instance I have x squared minus x minus 2 is greater than 0. The first thing that we will do is we will factor the inequality. So the factors of the inequality is x plus 1 times x minus 2. Take note that if we will double check this, the product of 1 and x is equal to 1x. Add it to the product of x and negative 2, so that is negative 2x. So 1x plus negative 2x is equal to negative x. So we are sure that these are the factors of the inequality. Then after that, we will equate this to 0 to find the values of x. So we can have x plus 1 is equal to 0, or x minus 2 is equal to 0. Solving for x, we have x is equal to negative 1, or x is equal to 2. So this will be the boundaries in our number line. So we have negative 1 as well as positive 2. Okay. So take note that this is a hollow because this is greater than. Okay. Next, we have three regions. We want to determine which of the following regions is or are parts of the solution. So let's have the following test points. So first, at x is equal to negative 2. Since this is to the left of negative 1, so we want to find out if this region is a part of the solution. So again, from our inequality, x squared minus x minus 2, then substitute negative 2. So negative 2 squared minus negative 2 minus 2. So we have 4 plus 4 minus 2. So we have here 4 is greater than 0. Okay, so meaning to say this is true. Next, on the other hand, if I'll choose a number or an integer between negative 1 and positive 2, I'll take 0 because that is the easiest one for our substitution, such that 0 squared minus 0 minus 2 is greater than 0. So again, simplifying it further, negative 2 is greater than 0. And this is false, meaning to say this region is not part of the solution. Next, if x is equal to 3, this is to the right of positive 2. So, again, substitute 3 to the given inequality. So we have 3 squared minus 3 minus 2. So we have this is equal to 9 minus 3 minus 2. So we have 4 is greater than 0. And we know that this is actually true. So therefore, okay, if we will graph our inequality, it means that this is from negative infinity to negative 1. This is not part of the solution. Then we have 2 until positive infinity. Therefore, the solution set is negative infinity until negative 1. Okay, so this is parenthesis, union 2 plus positive infinity. So let's try another example. I have x squared plus x is less than 12. First, I'll make this one in standard form, meaning to say I have x squared plus x minus 12 is less than 0. It means I subtract on both sides of the equation by 12. So, now this is now already in standard form. Then I can factor this one up as x plus 4 times x minus 3. So take note that 4 times x minus 3 times x is equal to positive x. So therefore, these are the factors of the given inequality. Next, we will equate this to 0. Then, find the value of x. So we can say that x plus 4 is equal to 0 or x minus 3 is equal to 0 using the 0 property. After that, we can say that x is equal to 4 or x is equal to 3. Now, again, on our number line, negative 4 and 3 are our boundaries. Okay? Then after that, we want to find out which of the following regions are actually part of the solution. So we want to find out by using our test points. Again, let's start with negative 5 because this is to the left of negative 4. Again, using the inequality, okay, then substitute the value of x, which is equal to negative 5. So negative 5 squared is 25 minus 5. Is it less than 12? So 20 is less than 12. So we can say this is false, meaning to say this region is not a part of the solution. Next one. So again, I'll choose 0 because this is the number between negative 4 and positive 3. This is the easiest value at this moment. So again, from our inequality x squared plus x is less than 12, substitute 0. So we can say that 0 is less than 12 and this is actually true. So it means that this region is a part of the solution. Let's move on to, okay, x is equal to 4. It means it is to the right of positive 3. So again, with our inequality, x squared plus x is less than 12. So substitute the value of x, which is equal to 4. It means 4 times 4 is 16 plus 4 is 20. Is it less than 12? So this is actually false. So we can say that this region is not part of the solution. So if we will shade the solution part or solution set, so we can say this is from negative 4 until positive 3. So therefore, the solution set is from negative 4 to positive 3. Let us move on to problem number 3. So let us consider this expression x plus 3 squared is greater than or equal to 2 times the expression x squared plus 7. The first thing that we will do is to distribute or simplify the given inequality. Meaning to say, if I had x plus 3 squared, meaning to say x plus 3 times x plus 3. Okay? Then we have here, we will distribute 2. So I have 2x squared plus 2 times 7 is equal to 14. Simplifying it further, I have now x times x is x squared. X times 3 is equal to 3x. Then 3 times x is 3x. Then 3 times 3 is equal to 9. It's greater than or equal to 2x squared plus 14. Simplifying it further, I can put now x squared, okay, transfer all these numbers, all this expression to the right side. So I have x squared minus 2x squared, then combine this together, 3x plus 3x is equal to 6x plus 9, minus 14 is greater than or equal to 0. Then, take note that x squared minus 2x squared is negative x squared plus 6x. 9 minus 14 is negative 5. It's greater than or equal to 0. So, again, I'll multiply both sides of the equation by negative 1 to make this negative x squared as positive. But take note that whenever you multiply or divide by negative, you will change the direction of the inequality such that negative 1 times negative x squared is equal to x squared minus 6x plus 5. But this time you interchange or change the direction of your inequality. From the previous solution, we found out that the expression x plus 3 squared is greater than or equal to 2 times x squared plus 7 is the same as x squared minus 6x plus 5 is less than or equal to 0. The next step is let's find the factors of this quadratic trinomial. So we have x minus 1 times x minus 5 is less than or equal to 0. By inspection, so we have negative 1 times x is negative x. Then x times negative 5 is negative 5x. And if we will add this together, we come up with negative 6x. So therefore, the factor of this trinomial x squared minus 6x plus 5 is x minus 1 times x minus 5. Okay, then after that, let's equate this to 0. So x minus 1 is equal to 0 or x minus 5 is equal to 0. Then after that, so x is equal to 1 or x is equal to 5. So these are our boundaries in our number line. Okay, but take note that this is less than or equal to 0. So if we will go back to our original inequality, meaning to say 1 and 5 are actually part of the solution. So that is why we put here guys, this, shaded part. Next, so we want to find out which of the following regions are actually part of the solution. So we will have our test points. So if x is equal to 0, this is to the left of positive 1. So again, we can use the factored form now. So this is the shorter way, okay, instead of using the original inequality. Again, let's substitute x is equal to 0. So we have 0 minus 1 times 0 minus 5 is less than or equal to 0. So we have 5 is less than or equal to 0. And this is actually false. So meaning to say, this region is not part of the solution. Next one, we will choose class x is equal to 2. Since 2 is between 1 and 5, so substitute with the given inequality, x minus 1 times x minus 5 is less than or equal to 0. So we have 2 minus 1 times 2 minus 5, and this will give us negative 3 is less than or equal to 0. And this is actually true. So it means this region is a part of the solution. Next, if x is equal to 6, meaning to say that this is to the right of 5. So again, so we will use the factored form. So we have x minus 1 times x minus 5 is less than or equal to 0. So we have 6 minus 1 times 6 minus 5 is less than or equal to 0. So 5 is less than or equal to 0, which is actually false. Meaning to say this region is not a part of the solution. So therefore, so the solution is from 1 to 5. Take note that I'll use bracket because this 1 and 5 is actually a part of the solution. To summarize our discussion in solving quadratic inequalities, we have move all terms to one side. Second is simplify and factor the quadratic expression. Third, find the roots of the corresponding quadratic equation. The fourth one is use the roots to divide the number line into regions. The last step is test each region using the inequality. That ends our lessons. Again, this is Teacher Onen Guzman. And don't forget to subscribe to my channel so that you will be notified about my new videos. Thank you once again.